Hi, I'm Colby.
Hello, I'm Other Colby.
Hi, I'm Claire.
Hi, I'm Marie.
And this is O'Neill Rabbithole. I love math, especially the parts of the field that schools just don't teach. Why does a squared plus b squared equal c squared? Why does 1 plus 1 equal 2? And what if it didn't equal 2? These are all questions that I'd love to be able to talk about on the O'Neill Rabbithole. What's up, everybody? This is the O'Neill Rabbithole, and today we're going to talk about all the things that you don't learn in school. In particular, we're going to address a little bit of something called set theory.
Hey, Colby, you forgot to introduce us. I'm Marie.
And I'm Claire.
Of course, how could I forget? Well,
Quite the oversight.
regardless, either way, like I said, we're going to start talking about something called set theory and why and what that has to do with teachers not teaching you what real math is. And
Which is
it
something that
seem-
we've never experienced here.
Yeah, teachers have never forgotten to teach us something
What do you
before.
mean, Colby, by teachers teaching us not the real thing? What do you mean?
Well, when you learn math, I don't know about you guys, but when I learn math in school, I learn a bunch of random equations that I have to learn how to plug into different situations. Is that what you guys learn?
Yeah,
Yeah.
it's a
Is that
lot
like
of, as Mr. Rayo would say, it's a lot of plug and chug.
That's a great phrase, very applicable to a variety of situations. But yeah, I get what you're saying, Colby.
Yeah, and as it turns out, believe it or not, real math is pretty much the exact opposite of that, especially in the last 100 years or so with the advent of calculators. Mathematicians didn't learn to just put their equations into calculators. We learned to look up the equations and continue doing what we've always done, which has nothing to do with learning equations. And I think set theory will be a very good example of it. So what do you guys think of when you think of the word set?
When you think of a set, you usually think of, at least I do, I think of two or more things grouped together.
Yeah. I think of like a box of like Christmas candy, but not the good type. The type that's really fancy, but it's mostly dark chocolate.
Why is it gotta be only the bad types?
Because the fancy boxes don't have any milk chocolate. It's like, we're fancy, we're adults. We only have chocolate liqueur. We don't have
Okay,
chocolate.
and second question, why are you against dark chocolate?
Exactly.
What's wrong with dark chocolate?
I'm sorry, I'm here to rot my teeth. Okay, if I want liqueur, I'll wait till I'm 21 because that's legal, and then I will go to a bar. I'm not gonna have cocoa liquor in my chocolate. I want cocoa butter.
Wow.
It's indecent. Next
I'm
you're gonna be
disappointed.
saying, why don't you like ruby chocolate? Which
Okay,
I've never
but
had.
I love ruby
what about
chocolate.
white chocolate, Maureen? How do
I
you
love
feel about white chocolate?
I do like white chocolate. Okay, speaking of chocolate,
See, I like white chocolate.
tangent here. Did you know that American chocolate it tastes like vomit? It's disgusting. We've all been tricked for years. The key ingredient that many scientists think is the secret of Hershey's, they put this thing in their milk to make it to last longer. And it's like butyric acid, which is literally what gives vomit its smell.
Oh,
And
no.
that's why Europeans, they come over, they're like, you eat this? You're eating vomit, ma'am, monsieur? Monsieur? I can't speak French. And it's because it literally tastes like vomit.
Have
And
you
if you-
tasted vomit before? I need
Have
to
you
ask.
vomited before, Colby?
I
It's
have,
impossible
but you
to
don't-
not
you don't-
taste it.
You don't feel it. You don't taste it for that long.
Yeah.
I can't think of the taste of
Have you never
vomit.
had the stomach flu? If you're
I have. No, I literally. No, okay. I'm not going. No, that's too gross. I'm not.
Anyways,
Yeah,
back
sorry.
to what we were talking about.
Okay, well, so we talked about a couple of different types of chocolates, right? So one set of chocolate could be the set of dark chocolate, right? It's just a collection of objects that all share something in common. And in this particular case, they're made of dark chocolate. And a second set could be white chocolate, or it could be a set composed of you randomly picking out chocolates from a collection of the other two sets, right? It could be anything you want it to. And set theory, it takes that idea and it applies it to mathematics in pretty much the simplest possible way that you could think of. First, it says that you can have a set of objects that has nothing in it, and that's called the empty set because it's empty. And then it says you can have a second set of objects that includes the set that has nothing. And then you can have a set that includes the set that has nothing. And you're creating all these new sets, and all it is you're saying that this set is made of some other set. And, well, think about it like this. You have a set of objects, right? And there's only two things you need to think of. What the set is, like what's it called, and what is inside of the set. And you can start off thinking, if you're going to look at it from a math perspective, if we're going to use it to define mathematics, it's very easy to just create a first set and say that this exists. You can have a set that has nothing in it. And then you have another set that has the empty set in it.
Folders inside of folders inside of folders?
Yeah, exactly. That's a good analogy.
So would an empty set in math be 0, or
It's a number,
is 0
though,
technically
right? It's a value.
a set?
So, okay,
What does
so
empty
to answer both of your guys' question, right? So the way we go from, I guess what you guys are thinking is, how do we go from this concept of like folders in folders in folders, and how do we turn that into numbers? And Claire, you suggested, what if the empty set was 0? And that is almost how we do it. We actually define, if I remember correctly, the first folder containing the empty set to be the number 0. And we just do that to make certain calculations with the empty set itself easier, because it's a very special kind of thing. Because it's the first thing we defined. We don't want to give it some other properties we don't want it to have.
So would the empty
it's
set
not even 0.
just be a lack of everything? So not even 0,
And
just a lack of anything.
A possible.
Yeah, so what's the point? So here's a question.
Well,
How
what's
do you
the
guys
point?
know
Like,
that you
what's
guys
the-
won't be going through math one day and just find like some kind of contradiction? Like, you won't derive an equation and it'll say 5 equals 4. How do you guys know that's not ever going to happen?
I probably will.
No, but what if you didn't make any errors?
I would, and it would be an arithmetic error.
Yeah.
I just know it would.
I don't know. I don't even know how I would react.
I mean, once I was in chemistry, and then someone went to the board, and they did, like, calculus, and the end result was 0 is 1.
Yeah, but clearly we don't want it to say
So
0
I
equals
guess
1.
that's happened.
So, like, the question was, sometimes we want it to say 0 equals 1, sure.
Right.
Well, sometimes,
But
yeah.
normally we don't
Most
want
of
it
the
to
time.
say something, to say both one thing and the other thing. We don't want it to say that they're both true. And mathematicians were getting really worried that maybe there was some
Right.
kind of contradiction somewhere, right? That maybe they hadn't defined everything sufficiently so that they couldn't, so maybe there was some kind of error in whatever they're doing, right? And so they were so the idea is to use set theory with its very basic rules, right?
Yeah.
To try to streamline all of math and to put it all under this one big umbrella, right? Because we have numbers, and we have geometry, and we have other things, we have calculus, we have, again, other things I'm not going to get into, but they took number theory, and they took calculus, and they took algebra, and they put all of them under this grand idea of set theory. It's called a foundational theory, because all other math can be built off of it.
Wow. That's crazy.
So they just,
That's-
like, went
yeah,
through
that's
their
a good
Google
way of doing
Drive
it, yeah.
figuratively and, like, cleaned it up and organized it.
I love that, Marie.
It's on my mind because I haven't done it this year yet.
So what if they did find
So the set
a
theory would show
contradiction?
them
How would the
more
set theory help
clearly
them resolve that?
where the contradiction is and what's wrong with it. Or at least that was the idea, right? as it turns out, that didn't quite happen the way they wanted it to, because in the late 1800s was when this whole thing was happening. This guy named Bertrand Russell created Russell's paradox, and he created, so let's take this side. If you have a small town filled with barbers and men, you have a small town filled with men, right? And other people, but you know what? Whatever. The original paradox dealt with men. Yeah, thank you. Thank you, guys.
I agree, Marie.
You have a barber, right? And he wants to cut people's hair. That's what he's paid to do. So he's going to cut everybody's hair that don't already cut their own hair, right? That's what because if you cut your own hair, you're not going to cut their hair. So he's going to cut everybody's hair that don't already cut their hair. And the question is, does the barber cut his own hair? So what would you guys...
Cut his own hair. I think I've heard this before.
Why can't... Because if he cut his own hair...
Why can't he cut his own hair?
Then he's only allowed to cut people who don't cut their own hair. So if he cuts his own hair, then he's not allowed to cut his hair.
Oh, I see.
Right.
So he gets a robot.
What
can he do? I thought you said
you know what? We can edit that out in post.
So I was like really confused.
Are they all cutting each other's hair?
No, I think we should leave it in. We should have to show that humanity is fallible. You know.
Or maybe we just should not have towns made up of only men.
Not allowed.
Yeah, I think that's what we get.
So Bertrand Russell took this idea and he extended it to sets, and so it was, you take the collection of all sets that don't contain themselves, right? Because some sets do contain themselves as a member. This one doesn't, right? Mm-hmm. He has the sets of all sets that don't contain themselves. And the question is, does this set contain itself?
That's so gross.
In the same way that the barber, if the barber cuts his hair, then he's not allowed to cut his hair. If he doesn't cut his hair, then he has to cut his hair. If the set contains itself, then it's not in the set. And if it doesn't contain itself, then it is in the set, so it contains itself. So it's a contradiction.
Wow.
Oh.
How would you guys?
I don't like that. It shouldn't
solve
exist.
It? What would you do?
There must be an answer somewhere.
Yeah, my brain is starting to hurt.
Okay.
I don't know.
I would change the rules of the game. So say he can cut everyone's hair. No, he can't cut anyone's hair who's...
okay.
It's such a tongue twister, but
he cuts their hair before
excluding
themselves.
No. So that's.
But then, if you say it's not in the set, it by nature becomes part of the set.
They redefined the nature of set, and they changed the rules, right, from this naive notion of folders to a more complicated notion that defined which sets were allowed to contain other things. So it's like a folder, but there's rules to what's allowed to go inside of each folder. And in this case, well, it's a folder except you can't put anything you want into it, right?
Isn't that just a folder?
To be fair, yeah, the limitations are very general.
I know.
You can do a lot of stuff with it,
so there's
but
limitations.
You can't do everything with it anymore. And one of those things that you can't do is create a set that contains sets which don't contain themselves. Very long-winded, but what is instead is it's called a proper class, and so it's not a set, and that's just the name they gave it.
Yeah.
So Colby, what are these new rules like then?
Folders. It was pretty easy to think of. At least, thank you for the analogy of folders within folders. It makes it very easy to think about. The new formulation that mathematicians thought of, they actually thought of a couple of different ones, and one of them kind of won out as the best one. But it includes, I think, 10 axioms or rules, right? Some of them are very complicated. Some of them are very simple. The first one says that the empty set exists. The second one says that if the empty set exists, a set containing the empty set exists. The third one it gets more complicated from there. And then on top of those 10 or so, there's 2 that are called axiom schemas, which are actually an infinite amount of other rules.
Whoa,
and so you see it gets very complicated very quickly.
Oh my goodness.
Yeah.
Infinite?
An infinite, so there's an because you have to create something
I'm
called
sorry.
functions, which they're kind of like the normal functions we think of, but you have to create sets based off of other sets, and each of those sets can have an infinite number of things in them, which
Yeah.
Oh, okay.
So it gets you have to create a lot of rules, and so then you have this big mess of rules, and the mess of rules is called ZFC, or Zernello-Frankel, after the names of the people, and then with choice, after the last thing that they added. And that's set theory. We started with choice. Okay, the axiom of choice says that given an arbitrarily long list of, even infinite list of sets, you can create a new set which takes one element out of each of the other sets, and so it chooses one element from each of them.
Mm-hmm.
And the axiom of choice says that you're allowed to do that.
I mean, that makes sense.
But
Like, why would you not be?
Yeah, it does, right? But it leads to some very counterintuitive results.
It's logical.
Yeah, which we can get into that later. It's Banach-Tarski has to do with, and we can talk about that on a later episode. But yeah, so it gets pretty complicated.
Yeah. Wow. Well, I've never thought of objects and numbers like that, Colby, so thank you for that insightful discussion.
Yeah, it's super fun stuff.
I mean, it makes my mind hurt a little bit, but
I'm a prisoner. I
it's
did not
interesting.
choose to do math. I was just curious one day, and then eventually I realized that I was in too deep. I couldn't escape. That's my excuse for liking math.
I get
It
it.
pains me.
Fair enough. I mean, I don't know if I've been thinking this whole time. I don't know what I've been doing, but I learned some new phrases.
Some new phrases.
Yes. Definitely a
Yes,
love-hate
sir.
relationship with math.
Yeah, I gotta say, sometimes I think it's cool, like when I can use it
Sure,
to do stuff
sure,
like
yeah.
science. But the moment you strip away the usefulness and you're just like, here's some numbers, here's some rules, and like
I
what
think
their interactions are, I'm like,
I
how
think
is this
math is
applicable?
the most
Don't show this to
cool
me.
when you can't apply it to anything. When it's so
That's
when
the
it's so
worst.
esoteric,
It's
when
so-
it's so out there
That's
that
terrible.
you just have no idea why someone would want to learn it. And then you can
But
Well,
it's like a jellyfish.
exactly.
Unpopular opinion.
It's amorphous. That is very unpopular.
It's so-
Clara, do you agree with
Which
that
side
or
are
not?
you
I do
on?
not agree with that,
Okay.
unfortunately.
Yeah, that's two no's to one.
I'm like
yes.
Marie. I like to have concrete stuff and know how to apply things.
Yeah, I'm not.
And why
I
does
don't
it
know.
matter?
I don't know. I feel like if you
Yeah.
know math, you can just like anybody can say something and you can say no, it's wrong, and then start shouting like a bunch of random 200-year-old mathematicians,
That's
and then you
the
win.
bad part.
You win
Where's
every
the
argument.
objective truth? No, that's
You
supposed
just have
be
to
limited
whip out
lawyers.
set theory
Exactly.
from your
You
pocket
say
and
no,
you'll be
but
good.
according to axiomatic set theory.
That is so unfair. Math should be like the most. I don't know. I feel like math should be yes, it's wrong, or no, it's right.
Or we can't
Wait,
prove.
whatever. Just right and
or
wrong.
it could be either. Or
Yeah, well,
it could
you
be.
have all the numbers available. You have all the numbers in the universe. Why can't you prove it? Tell me why. You have all these numbers, and you can make more, and you still can't figure
There's
it
too
out.
many numbers.
That's a
That's the answer
failure.
to that. That's what I'm gonna end this with. Thank you guys for listening to my rant about set theory. Hopefully our second episode will be a little bit less absurd. Either Claire or Marie will be introducing the topic for next episode. Make sure you guys tune in. And thanks for watching.
Yeah, thanks
Yes.
for listening.
Listening.
Yeah, thanks for watching, everyone. See you next time.